It took Amazon 6 years to deploy 100,000 robots across its warehouses. But in the last 2 years alone, that number has already doubled to 200,000. It's clear that Amazon is investing heavily in building its own robotic empire. From constructing a new $40 million robotics laboratory set to open in 2021, to hiring aerospace engineers to bolster its robotics division, the company is leaving no stone unturned. In this video, we'll explore Amazon's rapidly growing robotics landscape. We'll examine the various types of robots operating in their fulfillment centers and see how artificial intelligence is being used to predict what you'll buy before you even place an order. We'll also look at the technology Amazon is developing to make its human workers operate more like robots, such as a wristband designed to guide their hands, and consider what the future may hold. Could remote operators, sitting at home, control warehouse robots? This scenario is already being tested in Japan. At Amazon's Staten Island fulfillment center, robots deliver items to human workers, who then pick and pack the products. This human-robot alliance dramatically increases productivity, where a human might pack 100 items per hour alone. With robotic assistance, that number can reach 300 to 400 items. Still, according to the director of Amazon Robotics Fulfillment, the company is at least a decade away from fully automating the process of completing a single order without human intervention. Amazon first integrated robots into its fulfillment centers in 2012. By 2018, it had deployed approximately 100,000 of them. From 2018 to 2020, that number doubled to 200,000. While Amazon also employs roughly 250,000 human workers globally. These humans work alongside machines in what Amazon's robotics chief technologist calls a symphony of humans and machines functioning together. To keep this robotic fleet running smoothly and expanding rapidly, Amazon relies on key figures like Chief Technologist Ty Brady, who holds advanced degrees from MIT and has a background as a spacecraft engineer. Headquartered just outside of Boston, Amazon Robotics also maintains development centers elsewhere in the US and in Germany. To fuel future growth, Amazon is building a new $40 million robotics innovation hub outside of Boston. This facility will feature research and testing labs, as well as manufacturing space, to engineer and build next-generation robots. Now let's look at the robots Amazon currently deploys. The main workhorses in Amazon's fulfillment centers are the drive units, flat robots that navigate warehouse floors. These drive units, numbering around 200,000, move shelves of products to human pickers. They navigate by following a grid of barcodes on the floor and are equipped with sensors to avoid collisions with humans and other robots. Among these drive units are various models. The original Kiva robot can carry about 450 kilo, 1,000 LEBs, at a speed of 3 MNOP. The Hercules robot, a bigger and stronger version, can carry up to 1,360 kilo, 3,000 LEBs. The Pegasus units are shorter and can lift more weight than the original Kivas, but are also cheaper to manufacture, requiring fewer parts. Pegasus robots can be outfitted with a half-meter conveyor belt attachment, enabling them to drop parcels into chutes, significantly reducing sorting errors. In June 2019, Amazon introduced the Xanthus Drive Unit, a thinner robot with fewer parts and easier maintenance, which can be customized for different tasks and detect human-worn robotic vests. Beyond the drive units, Amazon also uses more traditional industrial robots. For example, the RoboStow is a giant robotic arm similar to those used in automotive assembly lines. It lifts heavy pallets with remarkable precision. Another category is the SLAM, scan, label, apply, manifest, machines, made by CTM labeling systems. Two such labeling robots can together label about 1 package per second. To understand Amazon's robotic success, we must go back to when the company purchased Kiva Systems in 2012 for $775 million. Before the acquisition, Kiva supplied robots to companies like Staples, Gap, and Walgreens. After the purchase, Amazon ceased external sales of these robots and integrated Kiva into its operations, forming Amazon Robotics. Since then, Amazon has made additional strategic acquisitions. In 2018, it bought Canvas Technology, a startup specializing in autonomous carts that navigate around humans. And in 2017, it acquired Dispatch, a company working on urban delivery robots. In 2020, Amazon acquired Zoox for $1.3 billion, a self-driving vehicle company that may pave the way for automated delivery vans, autonomous warehouse vehicles, and forklifts. Despite all these advancements, there's a holy grail in warehouse robotics that remains elusive. A robot capable of picking and packing items of various shapes, sizes, and weights as adeptly as a human. Humans still outperform machines in this area, and Amazon invests heavily in research to close this gap. They host annual robotics picking challenges to discover innovative solutions, and they explore numerous technologies to guide human workers more efficiently. To make humans more compatible with robotic workflows, Amazon introduced a robotic tech vest in 2019, now used at over 25 sites. Equipped with sensors, these vests signal to robots that a person is nearby, enhancing safety and allowing robots to navigate accordingly. Ideas like a wristband that guides a worker's hands with vibrations have surfaced, though this concept drew privacy concerns, and Amazon has considered lighting up shelves or using overhead cameras with displays to direct workers more quickly to items. As Amazon's robots buzz around fulfillment centers, the company continually seeks new ways to streamline operations. One vision for the future is remote-controlled warehouse robots managed by humans working from home. This is already being tested in Japan and could shape the future of Amazon's fulfillment model. What else lies ahead? Artificial intelligence is already predicting what customers might buy, pre-stocking local fulfillment centers to enable faster, cheaper delivery. Amazon Go stores allow customers to leave with items without going through a checkout line. Could similar seamless technology be integrated into Amazon's warehouses? Amazon's voice assistant, Alexa, may one day issue verbal instructions in fulfillment centers, just as voice-directed technology does in other shipping operations. On the connectivity front, Amazon is investing $10 billion in Project Kuiper, a satellite network poised to rival SpaceX's Starlink. This could maintain a robust global connection to direct autonomous deliveries by drones, driverless vehicles, and robots both inside and outside the warehouse. Speaking of deliveries, Amazon's robots aren't confined to the warehouse floor. The company is working on drones for aerial deliveries, as well as the Scout robot, an autonomous sidewalk rover that can bring packages to your door. In a fully robotic future, self-driving vans might release Scouts to drop off packages. These could communicate with your home's Ring doorbell system, or even interact with personal home robots. Meanwhile, Amazon's Ring Always Home Cam, a flying security drone, hints at a world where small autonomous devices patrol warehouses to identify and address issues. We may eventually reach a point where the entire delivery chain, from predicting your purchase to delivering it right inside your home, is automated. As we look forward, Amazon's robotic and AI-driven systems, fueled by continuous innovation, may bring that vision closer to reality. In our next episode of Venture City, we'll explore the future of the home office, where controlling warehouse robots from the comfort of your living room may be just the beginning. Don't forget to subscribe and give a thumbs up so you won't miss our future videos.